there are just a couple of basic formulas that we're going to use all the time. The first is that if you apply P of D to a complex exponential or a real one, it doesn't matter, the answer is you get just what you started with D substituted by alpha. So it's P of alpha. In other words, put an alpha wherever you saw D in the polynomial. And what is this? This is now just an ordinary complex number. And multiply that by what you started with, e to the alpha x. So that's a basic formula. It's called in the notes the substitution rule. Because the heart of it is you substitute for the D, you substitute alpha. Now, this hardly requires proof, but let's prove it just so you see, to reinforce things and make things go a little more slowly to make sure you're on board all the time. How would I prove that? Well, just calculate it out. What in fact is D squared plus AD plus B times e to the alpha x? Well, it's D squared e to the alpha x by linearity plus AD times e to the alpha x plus B times e to the alpha x. Well, what are these? What's the derivative of e to the alpha x? It's just alpha times e to the alpha x. What's the second derivative? Well, if you remember from the exam, you can do 10th derivatives now. So the second derivative is easy. It's alpha squared times e to the alpha x. In other words, this law, what I'm saying really is that this law is obviously, quote unquote, true. Okay, I'm not even going to put it in quotes. Yeah. It's obviously true for the operator D and the operator D squared. In other words, D of e to the alpha x equals alpha times e to the alpha x. D squared times e to the alpha x equals alpha squared times e to the alpha x. And therefore, it's true for linear combinations of these as well by linearity. So therefore, also true for P of D. And in fact, if you calculate it out, what is this? This is alpha squared e to the alpha x plus alpha e to the alpha x plus times the coefficient plus B times e to the alpha x. So it's in fact exactly this. It's e to the alpha x times alpha squared plus A alpha plus B.